4285. Stay on the right on 4285.
A history-making milestone in the Saturn program was reached during this report period, when the first Saturn flight vehicle, known as SA-1, was successfully launched from Cape Canaveral on the morning of October 27th. Flight of the vehicle, consisting of the S-1 booster, S-4 dummy second stage, S-5 dummy third stage, and dummy payload, appeared perfectly normal, and all test objectives were satisfactorily attained. For over a month before the actual launch, engineers and technicians of Marshall Space Flight Center's Launch Operations Directorate had been at work testing and checking out components of the complex vehicle in every way necessary to assure a successful test firing. Typical of the numerous tests conducted were this LOX load test, cable mast eject test, and support and hold-down arms checkout. In simulated flight tests, launch personnel in the Saturn blockhouse went through all the motions of an actual launch to thoroughly familiarize themselves with procedures and equipment. An important part of pre-launch preparation of the vehicle was installation of heat shields to protect the booster engine's fuel pumps, valves, instrumentation lines, control equipment, and other critical components. Temperatures around the booster's base would reach about 2,500 degrees Fahrenheit during flight. Numerous static firings back at the Marshall Center had already tested various materials of the heat shields. A specially insulated fiberglass fabric was finally chosen. Structural tests were also run to determine flexibility and strength of the heat shields during gimbaling of the booster's 4 outer engines. For this initial Saturn research and development firing, the first of 10 scheduled in the C-1 program, the inert upper stages were filled with water to simulate the weight of live stages. Total weight of SA-1 at liftoff was approximately 925,000 pounds. Fueling of the SA-1 booster, or first stage, with RP-1 fuel began 2 days prior to launch time. The other part of the propellant loading operation, addition of the liquid oxygen, would begin only about 5.5 hours before launch. At 11 p.m. Eastern Standard Time on Thursday, October 26th, the 10-hour countdown for the first Saturn launching began in the Saturn blockhouse. Not a single technical hold interrupted the countdown, although 2 holds were called because of low cloud layers which would have interfered with visual tracking and observation of the in-flight vehicle. Automatic fueling and sequencing operations were conducted satisfactorily. The countdown proceeded.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
At 10:06 a.m., Friday, October 27th, space history was written as the powerful 162-foot-tall rocket roared from its launch pedestal. Liftoff came 3.9 seconds after beginning of ignition. As planned, only 0.3 of a second separated ignition of all 8 H-1 engines, which generated thrust levels of 165,000 pounds each for a scheduled total stage thrust of 1.3 million pounds. Overall performance of the booster during flight was considered highly satisfactory. Wind shear encountered near the region of maximum dynamic pressure resulted in a predicted 4.5-degree engine deflection. But the disturbance was handled by the control system without difficulty. Structural integrity of the booster was maintained throughout. Performance of the propulsion system was very good. Ignition, transitions, main stage, and cutoff were as expected, with the measured combustion chamber pressures showing no major deviations. After the firing, inspection of ground support equipment and firing accessories indicated that only minor damage normally sustained for a flight of such nature was experienced. General condition of the GSE was better than expected. Post-flight evaluation of telemetry tapes processed later back at the Marshall Center's Computation Division verified the near-perfect functioning of the SA-1 vehicle and its ground support equipment. Static test firing of the booster for the second Saturn flight vehicle, SA-2, was completed at Marshall this quarter with the final test on October 31st. After static tests, modification and repair of the SA-2 booster was carried out in Marshall's Manufacturing Engineering Division. Final checkout of the SA-2 booster began November 22nd in the Quality Assurance Division. Launching of the SA-2 vehicle is scheduled for the first quarter of 1962. Assembly of the booster for the third Saturn vehicle, SA-3, was completed on December 26th. Fabrication of the booster for the fourth vehicle, SA-4, is complete, and assembly is due to begin in January 1962. Current plans are for 9 such boosters to be built at the Marshall Center. Approximately 20 more C-1 boosters will be made at Marshall's new Michoud operations 14 miles east of New Orleans under a contract recently negotiated with the Chrysler Corporation. Rehabilitation and modification of the $50 million facility, formerly the Michoud Ordnance Plant, began in mid-October. With almost 43 acres of usable area under one roof, Michoud is one of the nation's largest single-floor buildings. Chrysler's contract for approximately $200 million and extending through 1966 calls for the company to build, check out, test, and launch C-1 first stages. An advanced Saturn booster, the S-1B, with 3 million pounds of thrust, or double that of the present S-1 booster, will also be built at Michoud by a different contractor, the Boeing Company of Seattle. The $300 million contract, running through 1966, calls for development, construction, and test of 24 flight boosters, plus several ground test versions. About 50 miles from Michoud in southwest Mississippi will be the site of a huge new static test facility for Saturn and Nova-class launch vehicles. Operation of the site will be under direction of the Marshall Center. Construction will require 2 to 3 years, with 6 or more large test stands planned. At Marshall, construction began this quarter on the center's new 9-story, $4 million central laboratory and office facility, Nerve Center for direction of the Saturn program, as well as other NASA space programs, for work done both by Marshall and its numerous contractors throughout the United States. At Douglas Aircraft, contractor for the S-4 stage, the cold flow test program is underway with LOX flow from storage tank to battleship tank carried out this quarter. Installation of steam ejectors on test stand number 1 at Sacramento was also accomplished. In operation, these ejectors create the high-altitude vacuum necessary to start the S-4's engines at the proper exit pressures. The diffusers had already arrived from the vendors and were installed in the test stand. 2 hard mock-up RL-10A3 engines have been received by Douglas from Pratt & Whitney Aircraft and installed on the S-4 stage mock-up. At Pratt & Whitney's Florida Research and Development Center in West Palm Beach, the RL-10A1 engine, prototype of the A3, successfully completed its preliminary flight rating test on November 4th. Including acceptance tests, there were 26 firings, totaling 3,204 seconds. The total elapsed time to complete the PFRT endurance test was less than 5 days. Prior to successful completion of the PFRT, the RL-10A1 design was subjected to 712 development firings, totaling over 70,000 seconds. These tests included firing in vertical as well as horizontal attitudes, with several runs lasting over 10 minutes. The success of these firings was primarily attributed to many hours of component development testing, such as this propellant injector flow calibration. The torch ignition system was proven reliable in over 150 firings in an ignition rig. The A3 version of the RL-10 liquid hydrogen rocket engine, a mock-up of which is shown at left alongside an A1 engine, is being developed with higher specific impulse for the Saturn S4 stage and advanced Centaur vehicles. Minimum modifications to the A1 engine, such as this propellant utilization valve and this hydrogen collector manifold, are being incorporated into the A3 for improved performance. The North Engine Test Complex at the Pratt & Whitney Center has been modified to test the A3 engines at Saturn S4 conditions. Looking further to the future, development of an S2 upper stage for the C3 version of Saturn has been contracted to North American Aviation's Space and Information Division at Downey, California. The new stage will use 5 liquid oxygen-hydrogen engines, delivering a total thrust of 1 million pounds, which are being built by the Rocketdyne Division of North American under a separate contract. The 10-vehicle S2 development program will be under technical direction of the Marshall Space Flight Center.